good evening. This is Richard Hsu, host of Hsu Untied. This evening, I am really thrilled and honored to have with me as my guest Professor Stephen Wolfram, who's the creator of Mathematica, Wolfram Alpha, and the Wolfram language, the author of A New Kind of Science, the originator of Wolfram Physics Project, and the founder and CEO of Wolfram Research. Stephen, welcome to the program.
Thank you.
So, Stephen, I reached out to you initially to interview you because you, like myself, are a Caltech alum, and I love to have Caltech alums. Maybe you can start by just telling me why, I know you grew up in London, why you chose to go to Caltech so far away.
Well, gosh, let's see. My life story. Well, I grew up in England, as you observed, actually, mostly around Oxford, actually. I got interested in things like space because it was the 1960s, and that was the interesting, futuristic, cool thing that was techie that was going on. From that, I got interested in physics. And so by the time I was, I don't know, 11, 12 years old, I was fairly seriously involved in thinking about physics and reading college textbooks. And when I was, I guess, 12, 13 years old, I got to start actually using a computer to try and figure out things about physics. Actually, the project that I started back in 1972, I finally finished 50 years later. We can talk about that later. But then I went to a fancy high school in England called Eton, which is a bit older than the time when Columbus came to America, so to speak. So and it was I learned about lots of kinds of things there, but I sort of had my own separate side branch of studying physics. And by the time I was 14, 15 years old, I started doing research and publishing papers about physics and so on. And then, well, left high school when I was 16, went briefly to work at a government lab in England doing physics research, and then wound up as an undergraduate in Oxford. And gosh, let's see, by the first summer after I'd been an undergraduate, I was at Argonne National Lab near Chicago, and kind of doing particle physics research and so on. And I was like, okay, I'm through with the undergraduate experience. I'm going to go to graduate school somewhere. And so I was like, okay, what graduate school might I go to? And there were at that time 3 possibilities: Harvard, Princeton, or Caltech.
Okay.
And Harvard at that time said, oh, we can't take you if you don't have a college degree. Later on, they wanted me to be a professor there, but it's a separate story. I've never worked there. And then Princeton, I had visited. Caltech, I had not visited. And so I was like, well, I kind of know what Princeton is like. Maybe I'll go to Caltech instead. So that's how I wound up when I was, I guess, just turned 18 as a graduate student at Caltech. I guess I had in a slightly, I think I was sort of a notable character because there aren't a lot of teenagers who are doing particle physics research and so on. And so I was, I guess, at that time, well, Murray Gell-Mann was one of the sort of inventor of quarks, was one of the kind of big wheels of the Caltech physics department. And he was like, reaching out to me and saying, you should come to Caltech and so on. Not sure that was necessarily, I would necessarily trust his judgment in all things, but that's a different and later story, so to speak. But so anyway, aged 18, I showed up at Caltech, and well, I had a very productive time actually doing particle physics research. And I actually got to the point, I think my peak productivity was producing a paper every 2 or 3 weeks. I mean, I did have one important secret weapon, which is that I used computers to do things like mathematical computation, which for some weird reason, other people didn't do. Even though systems existed that could do those kinds of things with a bit of babysitting, other people just didn't use those tools. It's kind of a life lesson of trying to always use the tools that are available because they allow you to go further than you can with your sort of own unaided capabilities.
Interesting.
But so then that's how I wound up at Caltech, and I got my PhD by the time I was, I guess, just turned 20. I could easily have arranged to get my PhD while I was still a teenager, but at the time, it didn't occur to me as being something that would be cool to be able to say decades later, so to speak.
Yeah.
Um,
Well,
uh,
I saw on your website that you still have kept the record for perhaps the youngest student to get a Caltech PhD.
yes, I think that's right. I think that's right. The young woman who almost beat the record, and I kind of would have been fun if she had, but yes, I think so. I mean, I haven't tracked it in the last decade, but I kind of suspect that these the bureaucracies advance to the point where it becomes more and more difficult to kind of get through the system as quickly as I was able to.
Yeah. Now, now Caltech, a lot of people are surprised how small Caltech is because it has a big name. It's a very small campus. It's a very small student body. What did you think about that? Was that something that you knew about, or did you like that fact? What was your?
Oh, I had actually no idea. In fact, even after I'd been there, even after I was on the faculty there, I had no idea it was that small relative to other American universities.
Oh,
And when I sort of noticed that other American universities were much bigger, it was kind of a surprise. So much for, in modern times, I would have looked in Wolfram Alpha and seen, all the data on all these different places. But back in, circa 1978 or something, it wasn't so easy to go look up,
yeah.
how big is this place versus that place and so on. Obviously, one could have done it, but I didn't do it.
Hmm.
So yeah, to me, it didn't, I mean, I suppose it didn't strike me as that small in the sense there were plenty of physicists there.
Yeah.
There may have been very few students there, but there were plenty of professors there.
Yeah.
So it didn't and I, in fact, as I think about it right now, the theoretical physics, particle physics floor of a building, I'm not sure there are much bigger ones of those in many other places.
Mm-hmm.
So I think it's sort of a top-heavy organization with lots of professor types and rather few students.
Did you get a chance to enjoy Pasadena during your time there? It's a very nice city. I was just curious, did you get a chance to enjoy much of it?
Oh, it's gotten nicer since I was there, I think. It had evolved as some kind of retirement community, and I think it was I didn't have a lot of basis for comparison because I just moved from the UK to the US, and it's like, okay, this is an American city. I don't know. It's kind of, it's always notable in Los Angeles that there are in that whole area. To me, as a young British lad, seeing the sprinklers pop out to keep the grass green, even when the climate would not at all keep the grass green, was something that greatly amused me.
What was it like being? It seems like throughout your entire adult life, maybe continuing during time, everyone was always older than you. Was that something that you sort of got used to? Was it a problem for you in any way?
It's funny. It seems like as the years have gone by, there's almost no gap between when I'm the youngest person in the room and when I'm the oldest person in the room. It's kind of unfair, really. It's kind of like one would think that there was a long period of time when, but it's somehow it feels like it's like for many years I was always the youngest person in the room, and now I'm usually the oldest person in the room. So I think back when I was, I don't know, graduate student, faculty member, and so on at Caltech, at the time, it didn't strike me as particularly notable that there were lots of people who are much older than me. It's more obvious now because, I get to write a disappointing number of obituaries because the people that were my contemporaries were, considerably older than me.
Yeah, right.
At the time, I suppose it was, there were people who were off in later stages of life than I was. But since most of my interest was, doing physics research and so on, that wasn't particularly obvious. It's kind of like, somebody says, oh, my kids are doing X, Y, and Z, and their kids are my age type thing. It's kind of like, I can still, have a conversation with them about their kids, even though it's a little odd that we're off by a generation, so to speak. But I don't think that was terribly notable. I mean, I think in later times, I was, when I started my first company, for example, which was when I was at Caltech, actually, 1981, I guess, I had kind of at the time, I sort of backed into starting that company as a result of things at Caltech, actually. But then I kind of brought in, I didn't see myself as sort of a business leader type person. And so I brought in sort of people to lead the business side of the organization. And the main person I brought in was twice my age. And that turned out to have dynamics that were not perfect. It was, I suppose I'd had a previous experience actually when I was in Oxford, a person who was a sort of a bright young person in physics who happened to be twice my age. And who I think, as I later learnt, got very put out by the fact that somebody half his age was like, oh, I figured out this and that and the other thing. At the time, my friends who were kind of my age, so to speak, said to me, just wait until you're that age or older and some young whippersnapper comes along and they're like, let me tell you how this should work type thing, and they're half your age and so on. So every time things like that happen, I kind of remind myself of that, and it really amuses me, so to speak.
Now, you obviously gravitate towards physics at a super young age, but did you, when you were growing up, did you have an idea what you were going to do with, with your physics knowledge, or did you have any idea what you were going to do later as an adult?
Oh, I thought my plan from when I was 10 years old was to be a physicist.
Yeah.
That was my plan. The good news and bad news about that plan is that by the time I was 20 years old, I had exercised that plan, so to speak.
Yeah.
And then actually right at that time, I was like, okay, what's next, so to speak? And I happened to be doing physics at a time that was sort of a golden age for particle physics. I was very early in the kind of particle physics meets cosmology business and so on. But the thing that I kind of, first thing that happened was I just got my PhD. I was kind of trying to figure out what kinds of tools do I want to use going forward to do things as efficiently as I could. And I realized the tools didn't exist. And so that got me into building my first really big software system that turned into my first company and things like this. That was sort of my effort to make tools that I wanted to have, so to speak. And then actually, as a result of kind of a meltdown with Caltech, actually, I probably would still be a professor type at Caltech all these decades later if it hadn't been for the fact that we ran into all kinds of intellectual property machinations with Caltech, whose easiest solution was for me to just say, okay, I quit. And so that led me into, I went to work at the Institute for Advanced Study in Princeton. And but during the process of that unwinding, I had been like, let me just do something that's kind of fun. And so what I had ended up doing was thinking about some sort of other questions in science that I'd long been interested in, particularly kind of how do complex things end up happening in the natural world? And that got me into kind of studying sort of the artificial physics of the computational universe of possible programs, and sort of just run a program, see what it does. A tiny program, a program that you can just specify with a few bits of information. And the thing that happened was that because I was just doing this sort of for fun, it really helped in being able to discover things that I didn't expect to discover. Because like, what the heck, I can just run this program, I can do this computer experiment. It's a fun thing to do. And then looked at the results and like, oh my gosh, this is something quite interesting. So that sort of turned into a big area of basic science that I worked on in the earlier part of the 1980s. And that was kind of a part of my sort of lifetime of alternation between doing technology development and basic science, and kind of using the technology to do basic science, using the basic science to understand more about technology and so on.
Tell me a little bit about your book. I was sort of intrigued by it for no real the reason, the length of it. Tell me what possessed you to want to write that book, and what was that like?
A book called The New Kind of Science,
Yeah.
which is 1,280 pages long.
Yeah.
Actually, it ended up being as long as the limit of how thick we could bind the book. So it's kind of was absolutely of maximal length, so to speak. That was the result of sort of the outgrowth of the science that I did in the early 80s, of trying to understand sort of where does complexity come from in the world, and then realizing that this idea of using programs, sort of computational rules, as a basis for making models of things was something much more general. I mean, kind of the big picture is last 300 years or so, the sort of dominant idea in kind of making models of things in the world has been mathematics, mathematical equations, mathematical formulas, things like that. The thing that I realized was, well, that doesn't work very well for studying complicated kinds of processes in nature and elsewhere. And so it's like, what's plan B? Well, I realized sort of a good plan B is use computational rules and sort of just work out what those computational rules do. And so I then got interested in, well, what kind of science does one build by just studying this computational universe of possible rules? It's a very foundational kind of science, because these rules are kind of arbitrarily simple kinds of things. And it's like, well, what are the consequences of those rules? And so that's what I ended up studying. And I discovered a lot more than I expected to discover. What had happened, I started my current company in 1986 and developed, well, our first product and still big current product is Mathematica, system for doing kind of a computational language for sort of representing things in the world computationally and being able to compute things. That's something, I mean, I'm happy to say it's been used for many, many, many inventions, discoveries, educational kinds of things over the years. It's always fun that, 15 years later, somebody will tell me, by the way, this important thing in the world was developed using your computational system. That's always cool to hear. You don't usually hear about it at the time, but I built that system, Wolfram Language, what's been now called Wolfram Language, as a tool to use myself. And so the start of the company in 86, and then 1988, we released Mathematica, was immediately quite successful. By 1991, I had gotten to the situation where the company had grown pretty rapidly, but I had many more ideas about what the company might do than a company of a few hundred people could absorb. And so I was like, okay, let me throttle back on spending all my time kind of trying to inject ideas into the company, and let me do what I originally planned, to take the tools that I was building and do with them and do some basic science. So I thought, okay, I'm going to sort of take a sabbatical of maybe a year or a year and a half or something and figure out a bunch of what one can do with computational rules and what kind of science one can make from that. The sort of the thing that ended up happening was I just kept on discovering more and more stuff. And so that process that I had thought would be a year and a half stretched into 10 and a half years as the longest kind of single high tenacity project that I've ever had the chance to do. I've done a bunch of big projects, and in fact, something like Wolfram Language, which started in 86 and that I work on kind of every day all these years later, is probably sort of in aggregate a bigger project. But my book, New Kind of Science, was kind of the most concentrated, intense sort of personal project that I've ever done. And it's sort of a mixture of doing many computer experiments, trying to figure out their implications, and trying to make an exposition of them that was as kind of clear and minimal as possible. And for me, that was sort of the main mechanism for sort of clarifying the ideas that I had, was try and actually explain them in a sort of minimal clarity kind of way. And in the end, well, it took a decade to do all of that. And then in 2002, finally the book was finished. And I would say it was interesting because I had kind of known perfectly well that the things I was doing were kind of a really kind of a major separate prong from what people had done, which is why the title of the book was A New Kind of Science. It's kind of funny. Sometimes people who've been interviewing me and so on say, well, what was this book about, and kind of describe it. And they say, well, it's not like existing science. And eventually you say, well, that's why the book was called A New Kind of Science. But what's been interesting, when the book came out, I had known that I was packaging together a fairly big chunk of intellectual development. And I'd known that wasn't doable as, write 400 academic papers or something. The point would not have been understood. As it was, the form factor of releasing a big book rather than lots of little papers, so to speak, worked pretty well. Lots and lots of people read it. I would say that there were fields in which it got very rapidly absorbed, particularly fields which didn't have such high self-esteem at the time. Some of the softer sciences, arts kind of areas, and so on. The fields like physics that at the time had very high self-esteem were strangely resistant, even though those were my friends, so to speak, from that community. And I think I realized many years after the fact, I kind of realized how shocking that book must have been to many of those people, because it really is very paradigmatically different from the way that physics had developed with mathematical equations and things like this. I was looking back at these things just a few years ago for reasons I can explain, and I think there was a review of the book in the New York Times, I think, and it had a cartoon at the top, and the cartoon was a picture of a lecture room with a bunch of distinguished-looking physicists, and this monster coming in, and with some graphics that came from my book. And at the time, I hadn't really noticed, this, I thought it was a cute cartoon, whatever, but I hadn't really realized, I think the person who wrote it kind of recognized that the new kind of science was coming in and could be perceived as kind of eating what was there already. I don't think that's really a correct picture. I think these are things where there's an important prong of development that already happened and is ongoing from the mathematical direction for developing science. And there's a separate new kind of science, as the title of my book kind of said, that is using these kind of computational ideas. And it's been interesting to see that in the years since my book came out, there's been a silent revolution, in a sense, that when people make models of things today, they very rarely say, let me write down an equation for the thing. They much more often say, let me give a program that describes how the thing works. So that process, is 300 years of let's use equations to do this. And then in 25 years or something, there's been this transition to let's use programs to describe things. And that has many, many important intellectual consequences. But for me, it's I kind of knew something like that was going to happen. I think in the preface to the book, I kind of say, what's in this book will at first seem kind of shocking and surprising, and in time it will come to seem obvious. And it's interesting to see younger folk who have absorbed the things in the book and so on. A lot of the key ideas are obvious to them at this point. Couldn't be any other way. It's always interesting to see the transition from it's like you have to invent it, and people are saying, no, it can't possibly be that way. And then, a generation later, it's like, of course it's that way. How could it be any other way? But one of the things that was a kind of a use case for this new kind of science in the book was physics, fundamental physics, understanding how the universe is fundamentally put together, what's underneath space and time and all the other things that are features of our universe. And so I said a few things about that in the book. And then I was kind of wanted to pursue that further, but the physics community was like, my friends and physicists, I don't think anybody paid attention for more than 5 minutes in talking about this. So I like, the market doesn't want this. The market of people who will care about fundamental theories of physics don't don't want this. So I have plenty of other things to do. I'm going to do other things where people say, thank you for doing that thing. So I kind of left the fundamental physics direction for a long time. And then in 2018, I sort of had some little, I kept thinking about it a little bit. I had a little technical breakthrough. Then 2019, a couple of young physicists who had come to one of our summer schools were like, I told them about this little breakthrough I had, and they're like, you've got to work on this. You know, you can't just leave this undone. And by that point, I was ancient, and I was, you know, I think I had my 60th birthday, and I was like, look, if I'm ever going to do this, it's time for me to do this now. And so in the fall of 2019, started working on this kind of direction for understanding fundamental theory of physics. And to my great surprise, it went much more easily than I expected. And by early 2020, we'd really, I think, cracked sort of the major question of sort of how should physics be built underneath, so to speak. It's kind of about 100 years ago now, there was a lot of progress made in sort of the foundations of physics. And then there's sort of a 100-year hiatus. And then we were able to start making these advances again, which was pretty cool. I didn't expect that would happen. I thought this would be kind of a little tiny piece of what would be kind of a 100-year story to make further progress. But we were, I suppose, lucky in that it turned out with the tools we had and the ideas and so on, it's like one just managed to poke through and see how things worked. And so that's been sort of exciting for me as a kind of a piece of career that I didn't expect to have, so to speak. Very energetic time the last 4 or 5 years with science, basic science, and in fact the sort of the things figured out from this physics project now apply to mathematics and foundations of mathematics, a bunch of things about distributed computing, a bunch of things about biology. It's really kind of a wonderful thing because it's the sort of the formalism that we invented for physics ends up having all these applications in other places. It's a little bit like what happened with a new kind of science, where kind of that new paradigmatic idea of sort of using computational methods, using sort of computation as a foundation for things, opened up a bunch of investigations there. So now what we're doing, which I guess gets called multi-computational paradigm, sort of opened up a bunch of new things, and which is quite exciting and invigorating and so on. And in fact, it makes me, among other things, think, let me finish the other unfinished projects I have. And so one project I mentioned earlier from 1972 was a project about understanding the second law of thermodynamics, the law of entropy increase, the tendency of systems to kind of get more random over time. And that was something that people had worked on in the 1860s and beyond. And sort of people had said, well, there's got to be some way to derive this, but it hadn't really been figured out how that would actually work. And turns out that some ideas that came from our physics project, I had allowed one to finally see, I think, how that works. So I had figured out a certain amount about it in the 1980s from kind of earlier work that I'd done on kind of the computational universe of possible programs. But this was something that now finally, 50 years after I had first written programs to try to study the second law of thermodynamics and so on, finally managed to sort of figure out how it works, wrote a book about it last year, actually. It's kind of ironic that the program that I wrote back in 1972, 1973, on a very primitive computer program with paper tape and so on, at the time I thought my program didn't work. What I realized later is my program actually revealed something really interesting, but I was not ready to understand what it revealed, so to speak, at the time. And had I known what I knew decades later, I would have been like, wow, this is really exciting. At the time, it was like, I don't understand this looks wrong type thing. But it's been an interesting thing for me in recent years. Just there are a number of kind of big projects which have been which I've now invigorated with, also particularly with the methods developed from the physics project to try and really finish. It's also helped in, last year, the whole LLM AI story, which I had sort of seen the very early stages of. Back in 1981, I had worked on neural nets and I hadn't really managed to make neural nets do anything terribly interesting. And I figured I didn't see how they were going to do interesting things. And in fact, cellular automata, which are a sort of simpler computational system that I started studying at that time, I got to them by trying to simplify neural nets to the point where I could study things more effectively. And I always thought neural nets were kind of a messy, complicated thing that weren't of such interest. And of course, what the sort of discovery first a decade ago and then more recently a couple of years ago, that if you bash neural nets hard enough, they'll learn all kinds of interesting things, which was not an obvious discovery for anybody. Certainly I didn't see that coming, but that now opens up, that fact now allows me to go back to things that I was doing a long time ago and kind of rethink those things. In fact, I've just been working on a thing that relates to machine learning and actually also relates to biological evolution, where I'm thinking about this and I'm finding a minimal model and so on. And then I think to myself, I've worked on this before. And I realized in 1985, I had written a paper that is basically about the model that I'm now studying, but I didn't get that far with it. And now finally in 2024, I kind of have a different intuition from everything that's happened in machine learning and AI and so on. And now it looks like we're getting a long way with it. In fact, I was just working on it just before we started chatting here.
Well, let me ask you, as I'm listening to all these different things, how do you figure out what to work on? I mean, there's so many directions you can go to, there's so many different things you can do, not just in subject matter, but, you could be writing, you could be researching, you obviously run a business, that takes time. How do you allocate your time?
Well, I guess I have these sort of big projects that I'm doing. I have a sort of inventory of projects that I want to do at some point. And then there are things that opportunistically come along. And I would say about half the projects that I do are projects that I've been planning to do for decades, and half are things that come along because something happened in the world or I realized something that just opens up that possibility. And I'm at some level, I'm a fairly sequential worker in the sense that, right now I'm working on biological evolution. The next 2 weeks, I will work on biological evolution, along with running a company. And running the company for me is mostly about products and strategy and so on. And so I spend my sort of days mostly working on meeting with people, trying to figure out how we should build our product, what strategy we should follow, those kinds of things. And then when it isn't sort of, weekday working time, so to speak, then I'm working on projects that I'm doing, usually basic science kinds of things. I think that I have become reasonably efficient in the things that I do. And, it's helped by the fact that I have a great team of people that I work with, particularly at the company, where, I see the company as sort of being a machine for turning raw ideas that I have into sort of actual things in the world. And I've sort of developed it so that is how it works. The idea is to have the maximum effect with the minimum effort, so to speak. And there are projects that are going on, and the people who work with me kind of have an idea of when they're stuck and when I'm going to be able to help. And then it's like the 15 minutes of let me try to understand what's going on, let me try and use what experience I have and so on to try and figure out what to do next. Or I think I do best in projects which are completely open greenfield type projects where there's nothing, you got to figure out everything. It's and this is something every day I'm trying to sort of invent stuff where it's like, what are we going to do about this? Like today it was a bunch of AI types of things where it's like we're in a new situation. Nobody's ever had this opportunity and set of circumstances before, and it's like, what are we going to do? Okay, let's figure it out. Actually, one of my strange habits is that we live stream a bunch of our, for example, software design meetings, which has been kind of interesting the last 6 years or so now. It's kind of, I think it's the unique place in the world where you can actually see decisions getting made about sort of technology development like that. And I find that sort of interesting, and it has had some great feedback mechanisms with our users and other people and so on. But in terms of, how to spend one's time, I think, I got a company that I've sort of decided I'm going to put a certain amount of effort into things at the company. There are things I'm not going to do. There are things on particularly the commercial side of the company that I'm just not going to do, that I delegate to other people. Perhaps if I did them myself, they would be done better, stronger, faster. I don't know. But I sort of made the life decision that even though that will make the company be less commercially successful, it is a win for sort of the whole sort of portfolio of intellectual and other kinds of things that I can do and so on. So it's kind of a certain degree of strong-willedness, so to speak, to not get involved in things that I decide not to get involved in, so to speak. I think the other thing that really helps is that I spent my life building tools that make me efficient at doing the things that I do. And so there's an awful lot that I've been able to automate. And, in the project I'm working on right now, we're generating all these pictures and things. And it's like, these are pictures that people could have made a long time ago, but nobody did it. And they didn't do it, not probably because they didn't think of doing it. Maybe they thought of doing it, but it's just, we have really good tools. Yeah. And, with those tools, it's like, oh, well, maybe we should make this. Let's spend 10 minutes and try and do it. And then you have something that's done, and there it is. Whereas, without that tooling, it would have been, let's try and figure out how to do this. It might take a month type thing. And then you would never do it. And of course, the thing that has been my sort of, I suppose, one of my contributions to the world is the tools that I built for myself, everybody else can get to use too. Yeah. And that's been, it's been very satisfying to see all the things that, I don't know all the things, but to see even the small tip of the iceberg of things that people have been able to do with the tools that we built. And that's been a really nice thing. But I think, one of the things that is always interesting to me is when do I try to do project X? When is the right time to do it? And sometimes it's a matter of sort of the ambient situation in the world. There are things where, well, I could have done that project, like the Wolfram Alpha project, building a computational knowledge engine. I had thought about doing something like that when I was, first when I was like 12 years old, then again, quite seriously, when I was about 20 years old. And when I was 20 years old, for example, my conclusion was to build such an engine, we had to solve the general problem of AI. And at the time, I didn't see how to solve the general problem of AI. Then later on, it was when I wrote New Kind of Science, actually, one of the sort of philosophical conclusions of that book is that there's really no bright line between intelligence and mere computation. And so that philosophical conclusion made me realize, gosh, this sort of computational knowledge thing that I want to do, I can't have the excuse that I have to solve AI to do that anymore. So let me just see whether it's possible to do it using just sort of computational ideas, and turned out it was possible. It's always interesting in these projects, you invent something you think is possible, and sort of one of the big challenges of leadership for those kinds of things is to convince other people that the thing you think is possible, that they think is impossible, is actually worth trying to do. Yeah. And that's I think one of the in my efforts in leading our company and so on, that's probably one of the most significant kinds of things that one ends up having to do.
When you're not working, what do you do for fun?
My work is fun. I don't really have, I have at times had hobbies. Yeah. For example, when I was an academic, I had a hobby of doing strategy consulting for tech companies. I see. Okay. And that was, now that I've run a tech company for many years, I have a hobby of doing basic science. Nice. I have other hobbies, like I do live streams. That's kind of a hobby. A couple of times a week, I do a live stream about, started at the beginning of the pandemic, doing one about science and technology Q&A for kids and others. And then I have another one. I just did one today, for example, about Q&A about future of science and technology. So these are, I find these live streams relaxing, actually, and fun, and they kind of make me perhaps a better explainer, and they also raise questions that I hadn't otherwise thought of. and those are a good kind of hobby. I suppose in the things that I do, I have 4 kids, though they're all grown up now, so that's not so much of a thing one spends time on. But I typically in the past, my wife and I used to go see one movie a week. I never watched television or anything like that.
Yeah.
But these days, there aren't enough even faintly reasonable movies to see that's possible. But generally, that's been one of my other things. And I've also had various hobbies, like education is another kind of hobby of mine, where we have the summer school and now also winter school, which are times when we kind of we have one for grown-ups, one for high school students, actually another one for middle school students. That's a separate branch. But that's a 3-week thing where, in the case of the grown-ups, it's like 75 or so people who come to this thing that we put on. And my role there is sort of a time of extreme professoring or something. I don't do that the rest of the year, but at that time it's like make up projects for 75 people and kind of orient them in the right way and so on. And that's another kind of hobby of mine. It's I'm happy to say that some of the projects I've made up in the 20-something years of our summer school have turned into whole career-long adventures for people, which is pretty cool. But the thing that so that's another thing. I do a certain amount of I kind of find what are my other hobbies? I have another hobby. Another hobby is being an advisor to tech companies, and which is usually I view it as being mostly what I would call CEO counseling. It's like, usually you hear from people when there's some whole panic disaster happening. It's like, what do I do with this, that, and the other? That's one sort of branch of a hobby. Then I also do a certain amount of mentoring of kids. I found that there's a certain similarity between tech entrepreneurs and kids, that they're both sets of people where they sort of think that anything is possible. Sometimes often, perhaps not necessarily realistically in either case, but there's a certain similarity of energy there, which I like. And so that's kind of another hobby of mine. It's somehow the general arc of my life has been that most things that start as hobbies eventually become very real things. And same thing with or another sort of thing you could think of as a hobby is doing things like history of science kinds of investigations and writing and so on. And that's something which I guess it's a hobby. I don't know. I've published books and things like that based on that. But I guess for me, it's a hobby, so to speak.
Yeah.
And then it's a very different kind of work. Going to research a scientific biography, for example, is not as different as one might think. It's a problem-solving thing. It's like, what was the arc of this person's life? And there's a certain tendency for people to say, and then they discovered this amazing thing and it came out of nowhere. And that's always wrong. It's always the case. There's always a thread, might last a decade before the one moment when sort of now I understand what's happening. And I suppose it makes it a little bit easier for me to track those kinds of things, because it's happened to me a bunch of times too. And it's kind of like, I know that thing that, yes, on, June 1st, 1984, there's a particular picture that I saw that I generated on a computer. It's about to be the anniversary of that, that sort of opened up a bunch of things for me. But to realize that picture was significant had a 5-year history before that. Yeah. And that's typically what one finds. And it's always interesting when one does sort of scientific biography for other people. It's like, what was that thread? Can one uncover it? And sort of a problem-solving thing that I find interesting. I mean, I suppose if you're asking me about my hobbies, and I'm now describing lots of things that are hobbies, I suppose another thing, I find people interesting. The arcs of their lives and the choices that they make, I find interesting. That's probably a good trait for somebody who's run a company for, 37 years now, with lots of talented people, with lots of different personalities and lots of different quirks and so on. It's kind of being interested in people is a good thing, because otherwise they drive you crazy. Because but it's always I've never seen that particular thing happen before, but okay, I guess that happens, and that's kind of interesting.
Yeah.
And I suppose for me, there's a certain commonality of my interest in things like scientific biography and my interest in sort of talent development at our company and things like CEO counseling and so on, which are they're all somehow related.
Well, Stephen, I really appreciate your taking the time to speak with me. I know you're incredibly busy, so I really appreciate your taking this time to do this with me.
My pleasure. It was fun.
This is Richard Hsu and Stephen Wolfram. Thanks.